games in the garage. And very quickly signed contracts with hardware manufacturers such as Orange, Intel, PrimeSense. It was actually quite refreshing to see the previous IoT demo. Really cool stuff. To do that, usually hardware manufacturers would come to me with their device and needed applications to showcase the capabilities. So I would tailor a solution using C++ to leverage as much performance and wrapping it in Lua for flexibility. And back in March, I was going to GDC, as I do every year in San Francisco. I'm always crashing at Solomon's flat, and he was telling me about Docker as a platform and how it was turning. And I was telling him about my platform, and we just realized that we were in very different infrastructures, really solving the same problem, which is make developers' life easier and maximize creative iterations. So just a few words, because I had just landed last night. I landed from DockerCon in Barcelona, which was a great event. I would like to ask a few questions. How many of you are more like devs or ops? Could devs raise their hand? Wow, lots of devs. And how many of you are ops? Okay, great, good to know. So I guess nobody uses Docker in production here yet. Yay! Congrats, 2. Wow, that's pretty good. That's pretty good. How much of you? 3. The 4. How much of you? How many of you? Sorry, are using Windows as their development platform? Don't be ashamed. You know, there's nothing wrong with Windows. I like Windows. Most of the video game tools were in Windows, or only in Windows for a long time. And how many of you are developing on Mac? It's okay, it's an even spread. How many of you are using Kitematic? Or have, a few hands? And Docker Compose? Oh, okay, cool. And maybe Swarm? Docker Swarm? Yeah, you'll see I have some really exciting stuff to show you about Swarm. So just a little bit of background. Docker is an open source project that has a nice community, about 2,000 contributors. And it's not just contributors from San Francisco. They come from 63 different countries, organizing 215 groups. And to give you some numbers, right now we have 240K Dockerized applications, 60,000 Docker-related projects on GitHub. We just hit the 10,000 pull request milestone. Can you imagine that? It's insane. We close 200 pull requests a week. I'm talking about closing. And so a few big numbers. It ends up in terms of usage. It's 1.3 billion Docker Hub pulls, which in other ways is 5.6 million pulls every day, or 65 a second. 65, 130. That's what it is right now. So this creates, that's what I call traction, really. And such a traction creates a whole ecosystem around it. Everybody wants to be in. So welcome to the jungle. We have Amazon and Microsoft and Google offering infrastructure services to them, but we just announced that we acquired a great team based in Spain, in New York. And on top of that, we have orchestration layers, such as Swarm, our internal stack, or Mesos, more widely used in production, or Kubernetes from Google. And it's not just like a super tool for devs to be happy and that is not really production ready. Here are some of the brands that actually use Docker in production. And you can see the BBC, Yelp, eBay, Disney, big names. So let's jump back into the future, because I don't know if you guys noticed, but like a month back, it was the day Marty McFly said to jump into the future. And I'm sorry to say, guys, but we still don't have flying skateboards. But I believe that just like William Gibson, the future is now, it's just not evenly distributed. You know, all the elements are here, and it's really about putting the pieces together. And so what we're trying to do is to minimize the creative loop, and which makes our mission, a holy mission, to build tools of mass innovation. What we really want at Docker is to make your life, guys, easier. You know, it can be a mess. The internet is very fragmented. And so we separate at the moment our different steps into in between build, ship, and run. Meaning you can build your application locally, you can ship it as an immutable unit, and run it on the cloud. And I'm not talking about locking you down into a stack. I'm talking about any application, any software stack, any old stuff that your customer requires that is work, that you can actually now encapsulate into a container and move it around. And you can run it anywhere. You can run it locally on your computer, share it with your developer friend, and have exactly the same reaction, the same output. Or run it in the cloud and have no surprises. You know, I hear stories sometimes of projects in large companies, of course, that took just a few months to develop and 9 months to get into production. And can you imagine how big of an impact it has on the cost of the product? And basically, the internet is extremely fragmented, and that's what generates all this disparity. You've got a hardware layer that is made of very different architecture, very different software and language stacks, but technology is very fragmented. But think about it, the internet is something really amazing. It's been around for like, what, 60 years? Never broke. No one ever turned it off. So what we decided to do is to create a platform, a software layer to program the internet, because eventually that's what it is. And when you have a rich ecosystem like this, because a lot of people are wondering what is the business model of that. That's like one of the number one question I'll probably get at the end. But it creates a lot of business opportunities, because when you get to that kind of volume, new models start to emerge, and you don't have to have an entry level for a lot of your customers. And you know, CEOs see the money in it, because what it does is hide all the complexity of building an app, and you know, there's this guy that just knows how to do it. Well, now we tell him to do it once using Docker files, and we hide all this complexity, and it's no longer completely indispensable. But as Boromir would say, one does not simply build a PaaS. Because time, you know, building a PaaS is kind of too long, and you spend a lot of energy not focusing on a product. And time to market is essential. You know, if you miss the timeline, the competition will take care of you. And so there is this probably the worst acronym ever, MTYAMSH. So I'm not sure about how to pronounce it, but well, I like the idea behind it, which is mean time between idea and making stuff happen. More simply, I like to call it creative iteration loop, which is how long does it take in between your idea being coded, because we all know that writing the code is just 1% of programming. The real problems start to appear when you ship into production. So what we're trying to provide is agility, because agility saves time, and we all know time is money. So, you know, it's a really important thing. So now let's have a little look at the DevOps history. Initially, we had mainframe, you know, pretty simple, one push from one side, passive clients. Then we evolved into client-server architecture, struggle, you know. Then the web showed up, controlling both aspects. And finally, we're getting to an era where developers and ops can stop fighting and actually work together. And I even think that ops is becoming part of development because it's no longer just an app that you run on your computer. It's a whole system that has to work together and be shipped together. Let's look at why Docker is so different. And again, let's scroll back in time. The traditional architecture pre-2000 was one server, one application. Single stack, single language. If you needed more compute, simple, you needed more servers. Well, that turns out to be very expensive, slow, and inefficient. And then around the years 2000, virtualization appeared with products such as VMware, which meant one server equals multiple VMs and multiple stacks, multiple applications. You needed more compute, you just added a few VMs on your nodes and you could have them running completely isolated. Great, fantastic. You could have Windows running on Macs, Linux running on OS X. That really changed something, but it still emulated the whole hardware stack. You still had to have a separate memory space, and this was very costly in terms of CPU and memory. And the solution that we wrote, I wouldn't say we wrote, but we actually democratized, is the intermodal shipping container. Think about it as a box stuffed with things, and you can move it around, and you just don't give it that's what's inside. You just pass it to the next step, whether it's to QA, your developer friends, or live, and it just behaves the same. When I discovered Docker, I was just amazed by all the capabilities. For me, it's a real new Lego brick that has been invented. So it heavily relies. So what's the trick behind it? Well, the trick is that we don't emulate the whole hardware stack at all. Instead, we do a lot of tricks. So there's a lot of complex terms here that you don't really have to know. Really, there's three key parts. First is namespacing of processes, making sure that all the processes of a container only see each other and don't see the other processes. But they're really running on the host. And this is the key difference. We get the full capacity of the CPU, all the memory is not fragmented anymore. So that's one, namespacing. Then we need file system virtualization. If we're going to make that process believe that it's running inside his own operating system, inside the operating system, we need him to have his file system virtualized. And finally, all these containers need to communicate with each other, and that's why we have network virtualization, so that each container and services can have their own IP and communicate together. So then we structure things into layers for flexibility, because really what we have at the bottom is a kernel that references a base image, which would be like the operating system you want. Like here I chose Debian, which is one of the most common used, but you could have something as small as DevoxxMA. Then you add layers of content on top of the operating system, such as Emacs or Apache, and finally a writable container. So let's have a look at how technically it happens for developers. Here you have what we call a Docker file, so it's a description of how the service should be built. So you have a from statement that here pulls the latest Java 7 image that itself references a Debian. So we already have a stack just with one statement. We have a Linux machine that runs Debian that has the Java runtime and JDK installed on it. And then we copy docs where our source file, the source code resides, and put it inside /user/src/myapp. And we define a working gear to the same path, so we don't have to type long complicated path. And finally, we just run javac main Java and the last step is, of course, to execute it. So that's it, really. Here we have a container that builds your source code and creates an immutable image that you can run anywhere. And to build that image, pretty simple, Docker build. That's extremely creative. And really what you need to do is docker build dot, and it's going to look for a Docker file in the directory. But what is convenient is to tag -t, stands for tag, tag it with a name so you can reference it in the next command. So then you can just do a docker run, -it stands for interaction, rm to remove it, and you name your reference for my running app, and there you go, it's running. And it's really running instantaneously. It's not like super slow or anything. But sometimes you don't want to execute the application at the same time. So here the last line shows you how to actually do exactly the same thing as the Docker file at the top, but all in one command that just compiles. So there you go. Now the container is not an application, it's just a building environment, which secures and guarantees that developer A will build your app the same way as developer B. Another great feature. Because, it's a very versatile tool. It took me about, first time I really started to play with it, it took me about a week to really sink in all the concepts and all the possibilities that it opened. Docker Compose. Well, right now I described how to start and run one stack, but we all know that services are not just like one process running on a box. They're usually composed of, web front end, worker processes, databases. So you need them to work together, and they form a whole that you want to be shipped and moved around as a unit. So here you have two containers that are being described. We just named them. If you look at the top level tags, you have a web container, that is just a label that we chose, and a Redis container. So let's look at the Redis container. Very simple. Just like in the Docker file, we referenced Java 7 before. Here it's just referencing a Redis image. So it means it's going to pull an image and build and run it. And then for the web, because it's our source code, there's a little bit more tricks, but it still stands in like 7 lines. And it's going to instruct to build the current directory and then to run the Python app. You see, we were doing Java, now we're doing Python. And it's going to export the port 5000 from your, so it's visible from the outside of the container, and remap it to the port 5000 inside your app. Here's a Python app, export bind to port 5000. And then mount the source code into /code, because again, it's a completely new distro, fresh. We don't have to follow the Unix standards, and we can just put the code into /code or into /hello. We don't care. It's just going to be the same every time. And finally, we'll link this to containers. So you see, we find these three fundamentals that I named before, which is process isolation, file system virtualization, and network virtualization. Oh, sorry, I think lost the connection. Okay. Docker machine. Docker machine. So right now, so far I've only been talking about how we develop locally or how we compose a complex stack. But at some point you're going to want that into production. And again, production environment can be very fragmented. You have Amazon, AWS, or Azure, and Docker machine provides an abstraction layer that allows you to address any remote node on any hosting provider or your own node in the same way as you would locally. And that's a summary of the cloud providers and different operating systems that you can run into it, but really there's no limit. Kitematic is a high-level user interface that allows you, and that's for those of you who want to start using Docker, that's where I recommend you put your first efforts. You just download an app and install it, and it's going to offer you a bunch of images. I showed you a number of images that we have. I think that almost any source base that was available as open source has already been ported to Docker. any complex stack. Think about it before. You had like things like tutorials. I remember that used to be. It had an install procedure that was bad. Now this whole, and I never managed to do it. Like I tried a couple of times. I never managed to install it. Now if I wanna do it, which I don't, all I have to do is Docker run GitHub. Easy, and it's gonna work anywhere. So Kitmatic is gonna offer you a high-level interface allowing you to fetch any image and run it and see the status. And have a little preview, but I have a little video that I'll show you a little bit later. Docker Hub, so we need a place, Docker Hub is Docker's cloud service for publishing and discovering container images through the public registry. And it allows you basically team collaboration and automation of application workflow. But if you are in a corporate environment with high-level security regulation, you might not want your applications to be published publicly. No problem. You can actually take the hub and install it locally using what we call DTR, the Docker Trusted Registry, and have exactly the same process on-premise. And to make all this easy to configure and manage, Docker Trusted Registry also features a web-based GUI for insight into the state of a DTR host. There's another concept, because we have such a large community, you cannot imagine how many edge cases we receive about, oh, Docker is not working in this environment, oh, when I use it on this system, it's not behaving well. And that's the amazing stuff that we have with so much feedback, is that we can tailor the application to anybody's need, but sometimes these needs are really specific, and it doesn't make sense for us to integrate it. So what we provide in these scenarios is extension endpoints using plugins, and you can customize the Scalar plugin to integrate into Mesos, for instance, or the Volume plugin, or network plugins, or service discovery plugins. And Tulum on top of that, that we just acquired, is a really beautiful stack that's going to show a lot of potential in the next few months. So let's do a quick demo. So now you know a little bit of the principles and of the basics, and I'm going to show you a video of a really great guy I work with, and based out of London. It's going to show you what it is to start a job with Docker. Oh, I don't know if you guys can hear it. I guess not. So I'll do it.
To drag it to the other screen.
Oh yeah, thank you. That's not handy. How can I play a video on the screen? Can you help me with that?
There we go, almost.
Sorry, guys,
a little more. I've seen the side of there. Just drag it. You're almost there.
It's here.
Oh yeah, there we go.
Oh, thank you. We've got a scaling issue. Let's try and do that.
Make it full screen.
I should have embedded into the presentation. That's a shame because I really have a really cool demo. I can keep talking about it for hours. Anyway. Yeah, I don't know what's going on. It's like yeah. Huh?
Michelle?
Yes.
If you drag the window to the other screen so that we can see it there, and then press the
play button?
The green...
oh, the maximize button on this one? Okay, thank you.
It automatically scales.
Sorry guys. Resume in a minute.
Not this window, the other one.
Oh, so this is what it looks like to start with. I'll just you can't hear the sound here, right?
No.
Okay. So here, what Anna is doing is. Oh, okay. Well, it looks like you can get the sound too. Yeah. Alright, it's my first time doing this presentation. I'm not really used to it. So originally Docker was only Linux command line utility because it relies on Linux features. But we had a lot of developers asking for Docker support on Windows and Mac. And this is why we came up with that solution, which is using VirtualBox locally to virtualize a Linux system up. Can you turn it up?
So,
yeah, there you go.
Docker compose.yaml, they're using Docker, which means...
Okay, so let's start again.
Hi. So, I'm a developer, just started a new job at a banking company. They've assigned me to work on an app of theirs, but I've got a fresh work laptop, I've got nothing set up at all. Thankfully, they're using Docker, which means that all I have to do is install the Docker toolbox and I'm ready to go. So if I go to docker.com/dockertoolbox, you can see that it's available to download for Mac and Windows. Fortunately, I've already got it downloaded right here. So I'm just going to open up the installer. I'm going to go through the process of installing it really quickly. And off it goes. So this is going to install several things. It's going to install the Docker engine. It's going to install Docker Compose. It's going to install Kitematic as well. That's a visual management tool for managing Docker containers and images. So let's just get that started up in the background for a moment. And it also gives us the Quick Start terminal, which is just going to open up a shell that's pointed at my Docker engine, so it's ready to use. So I'm just going to cd to the directory where I've got the application checked out, and let's take a look at it. So the Docker compose.yaml contains a full description of the components of our app and the configuration that it needs to run. It's all Docker containers. We have 3 services. We've got web, worker, and Redis. So the web uses an image that's built from this web subdirectory here. It exposes port 5000 on the host, so we can talk to it, open it up in a browser, that kind of thing. And we also mount that web subdirectory inside the container as a volume. We'll see why that is in a moment. Okay, so we've also got a worker service. That builds an image using a worker subdirectory. And finally, we've got a Redis service, which uses the official Redis image from the Docker Hub, and also mounts a volume. It's a named volume, called my volume, and that will contain the Redis container data. And we'll see more about that in a second. So our worker is a Java app. If I have a look at its main class, you can see that it's doing some computation, connecting to a Redis up here, and then storing stuff in that Redis later. Okay. We can also see that it's got a Docker file, which starts from the official Java image on the Docker Hub, uses Maven to install dependencies, compiles the code, and sets it up to run from this jar file it's created. Okay, so quickly then, the web is a Python app. It also connects to Redis. It serves a static index page, and it has this API endpoint for reporting how much work has been done. So it also has a Docker file that uses the Python image from Docker Hub, bundles all of the stuff, installs dependencies, and sets it up to run the web server. Okay, so we've got those 3 things. all I need to do, even though I don't have Java or Python or Redis installed on my machine, is just type docker compose up. And I'm going to make use of the of Composer's experimental support for networking. So I'm going to pass this flag so that it uses the new networking stuff that's out in Engine 1.9. So off we go. So you can see here, the first thing it's doing is building the image for web using the Python image from the Docker Hub. Next thing it's doing is pulling the Redis image from Docker Hub. And finally, it's building the worker image, including compiling code and that kind of thing. So that's going to be done in a second. And there we go. So we can check that's all running. I type in PS. In fact, we can flip over to Kitematic, where we can see all three of these running. We've got Redis going. You can see it's producing logs as expected. We can also see that worker is running, and we can see that web is running, and not only that, but we actually get a preview of it. We can open up the interface in our browser right here. And here we go. We can see that it's generating, processing transactions at a rate of about 2 per second. So that's great. Now, I am actually supposed to be working on this app, not just watching it do its thing. So let's go back and make a change. I'm going to go into the CSS for the app, and I'm just going to tweak the color for the bar chart a bit to be a bit more interesting. So if I come back to Chrome and refresh, we can see the bars have updated. I didn't need to rebuild a container or anything like that, because didn't need to interrupt my workflow at all, because we've got the web code mounted directly inside the container. So we've got a nice iterative development cycle. Don't have to come out of anything we're doing. We've got really, really fast updates.
Okay.
Nice.
You guys like this?
Yeah.
So you see that iterative workflow, that's key. That's what I like, because all the rest is complicated. It took us a long time to build, but it's just plumbing. But when NN just changes the CS and the CSS and see it reloaded, that's exactly the direction. It's just the beginning of the kind of tools we are building now.
It's like Vagrant, huh?
So we might be able to switch change.
What's easier?
So Docker Engine is basically a daemon, and it has a CLI interface. You can issue a set of small commands. It's very simple, it's very clear, well documented, and but when you want to scale it into production and address multiple nodes at the same time, you can use Warn that has been built by us, so it follows the same philosophy. And basically, you just register nodes into your cluster and address the entire cluster as just exactly the same as if it was running locally. So it's extremely easy to start with. And not only is Docker open source, but it's also an open standard that we work in collaboration with a lot of companies to create what we call OpenCI, an open container initiative that allows other people to use our images, and which brought us to write runC, which extracts just the core execution of Docker without all the tools, the build system, which other competitors or partners can build their own way. But we standardize on the runC to avoid fragmentation again. That would be silly. We just created this common layer to harmonize the execution of a process on the internet. We want everybody to follow the same principle, especially with data adoption. And so Solomon Achius said as a joke once, Linux C potaret, run C potaret. If Linux can do it, run C can do it. Security is a big concern for us, and because we reinvented the execution of a process on the internet, now that process can be built from many different images that are pulled from different places. You have some official images, such as Ubuntu, so when you dictate your Docker file from Ubuntu. You trust Ubuntu basically to write it, but you might have high-level security requirements and require that any line of code that is running there has been validated and authorized by your IT security department. So what we need, of course, is signature. But again, we wanted to push things a little bit further, because security that is not flexible is just not security. If it's complicated to sign and push your stuff, it just doesn't work. You know, it's not, because at some point you're going to have a dev that pushes its private key to GitHub, and what's the point? So what we did is that we partnered with YubiKey to design a solution around the key that you can basically keep around your neck, and that recognizes finger touch and allows you to plug the key into your laptop and sign the content for distribution. And it's really great, and it allows you to recover from key compromises. You can very easily invalidate a key, and it's very handy. And you know, using your finger just to sign an image. How cool is that? 1.9 release. I'm going to scope a little bit more on what we just released for DockerCon. So the big headlights are network management, the top-level Docker network command, which brings us out of the box support for multi-host overlay networking. So even if these nodes couldn't see each other, magically we make them talk to each other. And of course, again, it's extensible for plugins. Because yeah, there's a concept that is really important to us. We call it battery included but removable. You know, any part that can be need to be altered in your specific environment, we want you to be able to swap it. Not like this thing, and it's battery that I cannot take it. And volume management, we've got Docker volume top-level command as well, and built-in node discovery. But we also improve build process refactoring, which still needs some improvements, but we now support the HTTP proxy, which was a high request for anyone of you working in a large company, of course. And quality, stability, performance improvement. You know, this is really one of our key goals these days. We really want to bring something that is not just working, but is really production ready. And the roadmap is for 1.10 is progress towards runs integration as a runtime environment for Docker. And distribution, rewrite the push-pull layers, and of course stabilize all the new features so that they're not an experimental anymore, and all that. So, orchestration. That's a big word. That's the big place where everybody sits these days. You have many solutions. I'm going to try to skip quite a little bit faster. So what do we have? We have Swarm out of the box, which is great, and I'm going to end with a Swarm video at the end that I think is pretty cool from a draft. And you've got Swarm that can address multiple hosts, just like I told you. It exposes several Docker engine as a single virtual machine, any sort of standard Docker API. And Swarm Scheduler, because you know it's kind of naive to think that you can just address a bunch of nodes in the same way. You might want different behavior depending on regions, different behavior depending on resources. Maybe you need 4 gigs of RAM for this specific app, so it should only go on the nodes that can take it. Or you know, define all kinds of sets of constraints. And we have, of course, a full integration of Swarm with Machine and Compose, which makes all this solution work out of the box. Mesos. Mesos is a great orchestration layer that is an open source Apache project, and it's a cluster resource manager that is scalable to up to 10,000 nodes. and it's fault tolerant, and it's battle tested. You know, it's really serious application, and provides an SDK for distributed apps. And just to give you an example, these are the companies that use Mesos in their production environment. Most of the time, running Docker containers underneath as well. Twitter, Airbnb, eBay, you know, it's not like jokers. And it's all supported by Mesosphere, which is the corporate behind Mesos that sells this solution. So we have a plugin that integrates into it. Kubernetes, a few words on Kubernetes. As I said before, you know, we didn't invent containers. Containers are basically a Linux feature, and Google has been using similar mechanics as their platform for their own internal services for about 10 years. They've been doing process isolation, virtual file system, overlay, networking, stuff like this for a long time. But they never saw the potential for a larger audience. You know, they really saw it as an internal tool, and here for production, you know, serious ops. Nobody would be interested into that. So when they saw how Docker became extremely popular, they launched Kubernetes, which starts to work now, but which is a very good solution, but it's very complicated. You know, I picked a tweet which made me laugh. What was it? I think it was, Kubernetes is so unopinionated that out of the box, it's simply useless. It has, you know, Kubernetes scalar, this notion of pod and replication controller. You just have a lot to grasp. But it's probably one of the most versatile tool as well. You know, I'm not trying to diminish its capabilities, but it has a high barrier at the entry. You know, it's going to take you a lot of time to get it running. Well, Docker, this is what made it successful. It's very simple and easy, and solves its problems. Cloud Foundry with IBM. IBM is a big partner of us. We sell a lot of things, but I'm going to skip through this part. This, I think I have. I'm sorry, guys, because I really want to show you the video about Swarm. I'm going to skip through some of the slides and just jump to the summary. Basically, we have Docker Swarm, which is Docker-style, really in-house solution. So, you know, nobody can work an else with us. It provisions Docker machine, and it's ready for production. And I have great news because, you know, it's been accused of not being production ready, and you know, it had a few bugs, and it was only working into some scenarios. I'm going to show you a little video that shows you how much we worked, because now we got to 1.0, and I consider it production ready. Mesos, Twitter style, aligned with Swarm, because we are plugin integration. So I think it's actually, if you have a very complex scenario, this is probably the orchestration that you want to use. But, you know, if it works out of the box with Swarm, you know, that's kind of what I recommend. Because this is like the ongoing battle these days. Like, should I use Mesos? Swarm is a joke. You should use Kubernetes. You know, my advice is just start with Swarm, because you're gonna have almost no effort to do. And if you have more complex requirements, just switch to Mesos or Kubernetes. And finally, Docker and Microsoft. Microsoft is a big partner of us. That's funny. I would have never guessed that. And we have Kitematic running on their platform. Docker Engine is built in Windows Server 2016 TP3. And Yo Docker helps you transition normal existing Dockerized application. And it has a Visual Studio integration. Should be still wondering about an answer to that. Probably going to be something you run in Visual Studio online and run, of course, Azure with the Docker agent, and on top of the Azure Container Services. So what's new with Swarm? Swarm goes stable. We're introducing Swarm 1.0, and we're really focused on production readiness, scalability, performance, and platform integration. And we ran some tests, and I'm going to show you a video about that, with about 1,000 nodes on AWS. And that's parallel scheduling, and it reached EC2 provisioning. We asserted performance, and I think that we got really low, median 117 milliseconds. That's not bad. And stability we stress tested under heavy load, because so far it was kind of our kind of not perfectly stable. Now it is awesome. And I'm gonna now show you a little video to demonstrate it. Okay, so here I'm doing, it's Andrea's demos. Docker info, and I'm showing you there's 10 nodes. So on this graph, you see each vertical line represents a node, and each layer represents a set of containers. So I'm going into the source code of my application, I'm doing the Docker compose up, and you see the little colors, shows the 5 components of this application. You've got Redis, a Java worker, a web front end. It's a voting application. It's very simple. It's actually what a lot of agencies spend their time doing, voting applications for grants. And here we did something quite controversial, Star Trek versus Star Wars. You see this is the front end to click. Star Trek 100%, and Star Wars, an incredible swing in the post. And so now, I'm just, that application got pushed to Facebook, and it's starting to have a lot of load. So now I just did Docker compose scale 50, and now I have 50 containers running it for the workers. I just specified I want 50 workers here. And now the application got super viral. Oh my God, what am I doing now? So we're jumping to the AWS console and adding the limit of 990 instances. So that video was sped up, of course. I wish AWS could launch so many instances that fast. But here we have 990 nodes running on AWS. So it's going to spin them up. And using the events, we see them populating our graph that is becoming a circle. And you see the number of containers at the top and the number of active nodes. And that's 1,000. There you go. And now we're going to start spreading all these containers over all these nodes and all this cluster of containers. And you've got the worker and the Nginx that are represented into different colors. And what you can see here is that as the containers are being spun up, you can see that an even distribution across all the nodes. And this is all handled automatically by Swarm to make sure that you don't have like 10 nodes and really working, 900 and doing nothing. And just to show you that it's not just a fluke, and that you can actually, even when you have 1,000 nodes, add or remove a few containers. You see here we have 1,000 nodes, which ends up being 50,000 containers. And we're just going to add another Redis and time it being half a second. It's running, you see, and remove it. There you go. So thank you. That was for the demo. Hold on, I think I still have a few slides. So yeah, fire up your first container today and start hacking, guys. I think if you never touched it, your mind's just going to go. It's one of the most amazing technology I've ever seen. And if you want to learn, here are a few links that I recommend as a starting point. Of course, the docs and but you'll see the amount of data and content around Docker that is available on the internet is crazy. And finally, we're hiring. We're a very fast-growing company with valuation to $1 billion now. We just doubled the number of developers over the last 9 months. And I wish we had some time for Q&A, but I don't want to, make the schedule off. So what about I'm ready for lunch? If any one of you wants